Chem Classroom with Auntie Taiwo. We are here again. If you have not subscribed, kindly do so. Okay, so today we'll be moving to chemical equilibrium. It's another beautiful one that needs to be touched. Yes. In some of our past videos, we talked about chemical reaction, which is just like a prerequisite to this one. And we're able to list some factors that affect chemical reaction. So today we'll be moving to chemical equilibrium. So let's go. Okay, so chemical equilibrium is a situation whereby you have a reversible reaction and the rate of the backward reaction and the forward reaction, they are equal. So that is when you said a reaction is at equilibrium. Yes. So we have some factors that affect the chemical equilibrium. We have temperature, we have pressure, and we have concentration. Okay, now mind you, catalyst does not affect the chemical equilibrium. Catalyst will not affect our chemical equilibrium. So please have that in mind, that catalyst only affects the rate of chemical reaction. So I'm going to list them on the board. I have temperature as the first one here. I have the pressure, and I have concentration. Okay, so starting with temperature, now when you want to relate it to temperature, you have to consider if the reaction is endothermic or exothermic. Now your endothermic reaction is the one that absorbs heat from the environment, and the heat change is positive, the delta H is positive. While for the exothermic, the heat change is being liberated, the heat is being liberated to the environment, whereby you have the delta H to be negative. You can be given some reactions. Nobody will tell you if it's endothermic or exothermic, but through the delta H, you will know if it's endothermic or exothermic. Now coming to the equilibrium, increase in temperature will favor the forward reaction in an endothermic reaction, while increase in temperature in exothermic reaction will favor the backward reaction, and vice versa. So if you are able to assimilate this, to understand this, you wouldn't have problems when we get to practical questions. Then the second one is pressure. Pressure is a bit unique in its own way and is one of the simplest. For example, when you have two children on a seesaw, one is 5 kg, the other one is 3 kg, you will agree with me that if I want to put a pressure, I'm definitely going to put pressure where I have a lesser weight, which is 3 kg. So now considering the formation of ammonia, yes, this is the formation of my ammonia. How many moles do I have here? Behind nitrogen, I have 1. Behind hydrogen, I have 3, making what? 4. Then behind ammonia, I have what? 2. So if I'm going to apply a pressure here, the pressure is going to be for the forward reaction, which is ammonia, because here I have 4. So I'm going to apply pressure to the side that has what? A lower pressure. So that means in this kind of reaction now, increase in temperature is going to favor the forward, increase in pressure rather, is going to favor the forward reaction. Yes. Then going to concentration, concentration is definitely going to favor the forward reaction, because when you have increase in temperature for the reactant side, the particles will collide in higher proportion and the forward reaction will be favored. Then one last thing we are going to talk about here is our equilibrium constant Kp. Yes, equilibrium constant Kp. I'm going to write for this reaction. I have the product over reactant for the forward reaction. So I'm going to have ammonia here in my square bracket. Then the number of mole is going to be as a square raised to power of 2. Then nitrogen, there is nothing behind nitrogen. Then I'm going to have hydrogen here. raised to power of 3. So if you are being asked to write the equilibrium constant for the forward reaction, this is what you are expected to write. So when next we meet, we'll be going to solve some practical standard questions under chemical equilibrium. So today we have been able to define chemical equilibrium. We explained the factors that affect, and I showed us how to write our equilibrium constant. So see you some other time in class. Tell your friends that something is happening on YouTube on Chem Classroom with Aunty Taiwo. See you in the next class. Thank you.